just running up to the North Valley, and I wanted to do a video, but I'm like, well, I got a little bit of drive time, so let's do the video. Basically, somebody of you guys, and I've received several questions like this over the years, which is about voice coil material. You can make a voice coil out of steel wire, gold wire, silver wire, nickel, lead, brass, basically anything that's conductive. A lot of you guys seem to be under the impression that a better conductor or a more efficient conductor will do a better job as a voice coil. And it's not just you. There's a lot of people in the industry. I think I talked about this a little bit in one of the most recent videos about there was an engineer guy that I talked to, and he was complaining about the copper quality of the coils that China was using, and I just chuckled, and he got a little mad at me, and he says, like, tell me, Chandler, what the fuck? And I go, and again, he was not a speaker engineer, so whatever. He's a really smart guy. He didn't know what he was talking about. So understand that the properties that you want to focus on for a voice coil have to do with the number of windings. It's the magnetic part of the voice coil that is important, not the conductor, right? Because aluminum is a good conductor, but copper is better. So, but when you start looking at the performance properties, it depends on your application. It depends on what you're trying to do. And so for most applications, as far as popularity goes, copper is the way to go, mostly because most speakers are small. They're not big monsters. So by far the most popular and easy to work with is copper. The problem with copper is that it's a commodity, and so if you look at the spot price of copper right now, it's like $5.30, $5.40, and that gets very, very expensive. What you find out though is when you start making your own coils, you're like, these guys are just bitching about their margin, and they're making a good margin. So Omar Rodriguez figured out how to get. I think he's only using. He's using one of those little Harbor Freight mini wood lathes, which again you can do, and you can even modify like the motor from a sewing machine or something like that. There's all kinds of things that you could do. That way you can use a foot pedal to control the rotation speed and on off and all that kind of stuff. That's another way to do it. And then he was able to I think he buys the formers, which is just a little piece of aluminum from China, and then you just buy the Kapton and the Nomex. So but as far as materials go for the actual coil, what you're really looking at, like I said, is the number of turns. Now, if one voice coil has, let's say, 20 more turns than the other, like let's say they're different sizes and things like that, does that make a big difference in performance? No. The answer is no. There's a certain sort of like sweet spot where even if you're doing a 2-layer coil, which is typically half the windings, of course, of a 4-layer equivalent, you still don't get, like, it's not proportional. So I'm sure the algorithm it's logarithmic, and it's not linear as far as what the graph looks like. But aluminum works as a good conductor. Like I said, you can use brass, just as long as with the wire that you're using is enameled, like it's insulated. Because otherwise, if it's just raw wire, then that's just a clump of wire. That doesn't mean anything. So it's the insulation in between the windings and the coil from touching itself is what creates the magnetic polar force whenever you apply flux to something like that, right? Which is, you can actually do something where you just put like an iron core in it, and then you apply a DC voltage, and you can see it move just based on the iron core. that it's reacting with. So, because on its own it creates a field, but when you start including ferrous materials and even a counter field, then it gets much more sensitive. It gets much more efficient in turning that electricity into motion, which is what you're looking to do. And so I think that was it. If you go back and look, I think I did a video on the differences of a quad copper coil that was it was I got it as part of the concept buyout, and it was an 8-layer copper 3-inch, and each layer was yielding a 1 ohm load. So that's what I wanted to cover was if you do use better conductor materials, like let's say gold, right? A lot of people like gold or silver as a conductor, and it is slightly better than copper. It's certainly not worth it, but let's just play around with it real quick. What you're going to find out real quick is that silver and gold are both more dense. They have a higher, I don't know how to describe it, specific gravity, like a certain ounce per like cubic centimeter. They're more dense, and so and also being a better conductor means that you have to make the wire actually smaller in order to get that resistance, because that's what the amplifier likes. The amplifier has also a sweet spot that it's designed for a range of impedance. And again, impedance is just resistance over an AC circuit. And a music circuit, like what an amplifier provides, is a AC circuit. It's just the alternation is queued up with the music. That's what creates it. So it's alternating to the frequencies of the music rather than just like a sine wave where it's a tone of some sort. And then, you know, if you look at your regular household outlet, that's a 60 hertz sine wave. And so again, if you like, 60 hertz, just plug it into the wall and then control the resistance to it as far as the voltage goes. But so let's go back to the silver conductor. So if you use a silver conductor, what you're going to find out is that the wire is going to be really, really thin, and so you're going to need a lot more turns. Again, it depends on your gap as well. If it's a really, really thin gap, that might be a good way to go, and it also depends on your application. So, but you're not necessarily looking for the best conductor in that situation. What you're really looking for is to be in that sweet spot of the number of turns, which in my experience is typically about 100. Again, it depends on your application, it depends on what you're doing. And there are other properties that start messing with the power handling and how much flux you're working with, how much surface area you have. The other one that people don't seem to understand or keep promoting the false information of that flat wire somehow has more surface area than other types like round wire, and that's not true at all. So if you just look at a corrugated roof is corrugated for a couple reasons, but most of that is to basically jam more material and also have a angle of attack to resist flexing. It's to make it stronger. So that's what corrugation does. Now, when you look at the profile, the side view of a round wire coil, you'll see those little like corrugations where it's a little loop, a little bump over and over again. That provides you more surface area than what would be flat wire in the same on the same coil. I'm gonna go ahead and let them in. So, and you're not the differences in performance are going to be nil. But it's one of those arguments where technically, if you're saying that flat wire has more surface area than a equivalent round wire, like in the same gap, you are wrong. And you just got to look at the physics of it. The example that I gave to someone was if you look at an amplifier, and all things being equal, you want to have an amplifier with more surface area. And so, do you have to have surface area? No, that's just one way to go. There are other ways to augment it, like with a fan or thermal mass. It can be bigger and heavier, but you got to make up for that if you're not going to use fins. One good example of this is the old, like from 2005, 2006, RE audio amplifiers. I think it was 1000.1. I love that heatsink design. Or let's use a more popular amplifier like the Art series from PPI, the old Art series. Those did not have fins on them. So, but as a expensive option, the engineers designed into it the ability to liquid cool them, where basically you're using the liquid to capture the heat and then go to a heat sink of sorts somewhere else on the vehicle that is either in a different environment, like the air-conditioned part of the cabin, and also has a heat sink with lots and lots of fins, lots of surface area. And so that's another way to get rid of the heat. But the easiest way is just to make an amplifier with a bunch of fins on it. And then you start getting into very minute changes depending on the finish of the heat sink. Like if it's metal plated, that does not help. That hurts. Especially if it's heavy chrome plating, that does not help. So now if you look at something like later on in PPI, when they started doing that with some of the power class amplifiers, what you got to remember is that on the inside of a lot of those bigger amplifiers, they had a fan. Now, when you add moving air, like actively moving air on any sort of heat sink, especially when there's fins, typically it increases by a factor of 3. So it's like having, there we go. It's like having 3 times the heat sink size whenever you use a fan. Some people though, and also, in some circles of thought, you don't want to have a moving device that is electromechanical near an audio circuit, and I understand that. And so, but if you can get away with it, where like PPI did, where you're not hearing the noise of the fan and the EMF isn't bleeding over into any part of the circuit, yeah, go for it. It's fine. So, but again, that's just another way to design a heatsink, and also to take advantage of certain materials properties that are inherent or that you've gone with. So like doing a chrome finish is not great for heat dissipation. However, chrome looks fancier and it sells the amplifier. And if the amplifier does not get sold, where are they going? If the amplifier does not get sold, then it's a turd. It doesn't do anything. So the amplifier has to get sold, and so you end up as a designer figuring out what looks good, what people want, and then going from there. I do appreciate what JP has done for the industry, which was that yes, it costs a little bit more, and his MLQ on those is probably like 1,000 pieces each for those down for sound heat sinks, the green, the pink, the yellow, the blue, and all that kind of stuff. And so it cost him a little bit more money, but people really, really like that. And so that's one way to go to make a successful amplifier get into the market. Now, as far as the quality of the amplifiers go, they're as good as anything else. So to me, they look like clones of the old CT Sounds amplifiers, and whatever. None of that shit really matters. It just matters about performance, and then what you could go back to is as far as a rating goes. So basically, like JL did with the 1000/1 and the 500/1, is that the 500/1 is a 1,000 watt amplifier, but they regulate it, with so that you can only use half of it. And so what ends up happening is the amplifier is really efficient, and it lasts a really long time because you're never able to really max it out. Does that make sense? So, and the same thing with the 1000/1. It's actually a 2200 watt amplifier, but they never allow you access to that much power so that the devices never get really hot, and it tends to not clip unless you're really aggressive with that. And then that's what you saw in the changes of the V1 to the V2, is they added the clipping indicator and also a thermal indicator if you're pushing it too hard. And and again, that's just a marketing thing, because when you start maxing it out like that, then all of a sudden JL's like, well, sounds like you need another amp, and then they sell you a second $1,000 amp, and that's how that works for them. So, but right now you can get about a 3,000 watt amplifier for $100, and I'd recommend that. But I'd recommend that you just use it at, like, it's 1 ohm stable, but just use it at 2 ohm, and then only try to run it, again, not clipping. Just be gentle with it. So if you're gentle with your equipment, it lasts a lot longer, and that power, they're basically giving away the power at that point. And so if you just are gentle with it, it'll last you a really long time. I think that was it as far as voice coil wire material. And you don't need a really thick gauge. The bigger gauge that you go with on a voice coil does not matter either. It doesn't make it like less prone to burn or something like that. Can it take a little bit more current? It depends. And so that depends on how many layers are there. If it's a 2-layer, a 4-layer, impedance really doesn't matter, because that ends up going back to the properties of the amplifier and the system that you're working within. Sometimes you want a dual 1/4 ohm voice coil. Again, it depends on the amplifier. It depends on how you're using the subwoofers. So I personally found out and figured out, because I made a pair of, I was using those dual 0.25 voice coils from Lord of Bass, and I ended up making 2 beefy 12s. And what I realized was that it actually takes away from the BL force. So it's not as efficient, but it drove the amplifier. Again, the amplifier doesn't care. It puts out a certain voltage at a certain impedance, and that impedance in this case was wiring all 4 voice coils in series for a 1 ohm load. But what I did find out about the subs was that they did not respond as well as they could have. So watch yourself in using low impedance coils, and also in loading down your amplifier really low to get all the power out of it. Stop doing that. Use a higher impedance coil. I think Bruce George said it best, which was when he did his hearse, which I think it was 8 or 12 12s, and these were just his branded 12s for his shop that he was getting Gefco to make for him, which was also the build house for JL Audio at the time. And he did 8 ohm subs, which was just a sub that they had off the shelf that a lot of people used for home audio. And then I think he ran an A1200 per sub. And so what do you know? The thing ran super clean. It was super clear. It was super punchy. And if that's what you're looking for, then that's the way to go. So, or I should say, that's one way to go. But I'm getting off here, way up here on 67th Avenue. But that's it. Keep the questions coming. I love you guys. I'm going to be working all through the holidays. I don't celebrate the way that I think you guys can celebrate Christmas and have the Christmas spirit with you every day of the year, not just on Christmas. And our Lord Gonzo says that we should love each other, and we're here to learn stuff, and you can do that every moment of every day. It doesn't matter if you're in prison. It doesn't matter if you're in a shithole country. It doesn't matter if you drive a Jeep. Fucking Jeeps, stupid Jeeps, or a stupid Jeep. It doesn't, that doesn't matter. So you can still, even if you're a bad person and you know you're a bad person, you can still do good things. So again, keep the questions coming. I love you guys. Thank you very much, and we'll talk to you later.